I'm going to talk about reactive programming in the context of React and Redux. My name is Marcus Stenbeck, and I'm a team lead and a front-end developer here at Acast. I've been programming probably since I was 14 and figured out that, well, if I can code, I can make a web page for my band, and then we're going to get famous. We didn't get famous, so I'm a coder now. For this talk, I assume that you're familiar with React and Redux. How many in here are familiar with React and Redux and have it? All right, cool. We've got pretty a good portion of people. So let's start off pretty low, like bring it all the way down and talk about what reactive programming is. And this right now is my mental model that kind of makes me understand what it is. Essentially, it's about lines and balls. So this is what's going on in my head. You basically got the line, which represents time, and the ball represents the values that go onto this line in time. All the way on the right-hand side, we have a little thing that represents that the time has ended, and we're going to talk about that a little more. If you've looked at this before, you've probably seen something like this, and this is from a great article called, I think, the Intro to Reactive Programming that you've been missing. And what this picture essentially illustrates is this black timeline and then the values that go onto this timeline. So the yellow value is first, the green value is what comes second onto this timeline, the other green value is what comes third, and the blue one's the last value that actually comes onto this timeline. We've also got the notation for the end of that timeline and also an error. We won't be looking into the errors today, but we'll talk a little bit about completion of what's called a stream. So reactive programming is lines, that represents time, and balls, that would represent the values. And as I kind of touched on, lines and balls together are called streams. So this picture, that's a stream. And it's got values or events or whatever you want to call it on the stream. So yeah, reactive programming is streams. And if you start diving deeper into reactive programming, streams is really such a core concept that make sure that you understand it. It's kind of like one of those math concepts that are so fundamental that if you kind of have holes in your understanding of it and continue building up, you might make other mistakes in the future. So really, if you want to know more about this, make sure that you understand streams at a foundational level. So let's jump into a little crash course on reactive programming. So to get a stream, you would create an observable. And an observable and a stream, you can pretty much interchangeably use those. Of course, there's like some technical differences. Stream is maybe more of a conceptual thing, while observable may have to do with more implementation in whatever programming language you're doing reactive in. Hint, hint, we're going to use JavaScript. So let's jump into the first example. We're going to subscribe to an observable. In other words, we're going to create a stream. So I've jumped over here to JSBin, and I'm going to create something called a tick stream. And I'm using RxJS. And hold on, create an interval that every 1,000 milliseconds it'll emit a value, and it'll start at 0 and then increment up one value at a time. But as you can see, alas, we have nothing in the console. So to actually do something with the values that appear on the stream, they don't actually appear yet. They only appear when you observe them. So we gotta subscribe to it. So what we're gonna do is we're going to subscribe subscribe to that stream, and it takes a function as an argument, and the function gets the value on the stream as its argument. So I'm just going to throw console log on that, so it logs it out to the console. And if we run this, we should, yeah, there we go. It starts counting up from 0 to infinity. We can stay all night. It's not going to get any more exciting than this. Let's jump back. So observables can be created from events. I kind of hinted on that by using the word events. That's a heck of a lot more interesting than just having something count upwards. Maybe you want to make a timer, then counting upwards is fine. But we want to make something cooler. So the most canonical example is creating the events from the mouse clicks. So let's jump back. And I have some prepared stuff here. So I'm going to copy this. And the stuff I'm copying over right now, it's essentially just adding some elements and some UIs, and it has update marker position for updating this little white ball. So what we're going to do first, I'm going to copy this over too so I don't do typos. And then we're going to talk about it. Can everyone see that? This right here? Yeah. No one can see it. So I create a variable and I call it clickstream. Okay, yeah, I forgot to mention this $sign at the end just indicates that it's a stream. You can call it whatever you want. You can't make me call it anything else in this. But I'm creating a new observable from an event. And I'm looking at this blue box and listening to the clicks. So every time I click in this, it's going to put that event onto the click stream. So what we're going to do next is we're just going to, hold on, copy over the code that renders this. So we're taking the click stream, we're subscribing to it, and out of this native click event, I'm just picking out the client X and client Y, and I'm updating the market position. And let's run this, and if I click now, dear God, it moves. Wonderful. All right, cool. Let's jump back into this, and let me start my slides. So that's pretty cool, but it's basically nothing more than a standard event listener. But what's cool about streams is that you can use operators on a stream and then it'll create a new stream. And again, borrowing from that intro article, I've borrowed this picture. So we start up here. This is actually what we built in the previous example. We start with a stream that contains all the clicks. And then we can use different operators to create new streams that represent something else that we want to do with those values. So in this example, we're buffering this, and it starts buffering when it gets an event, and then it keeps putting the values in a bag for 250 milliseconds. And when 250 milliseconds is done, it's going to give you that bag, and that's the second stream. And then you can map that and get the length of that array, because each value here is an array. And you would get 1, 2, 1, and 3. And then you could filter that stream onto another stream that only contains values that are larger than 2. And that's how you would essentially figure out what's a double click. If you recognize this, yes. It's very similar to how array functions work in JavaScript and many other languages. You get a new array back after running your array operators on them. So next up, we're actually going to do this double click thing. So to start off, I have more cheat codes. And what this adds right now is it adds a dark circle that'll show me where double clicks are. And if I double click now, click, click, nothing happens, click, click, nothing happens. So what we want to do now is we want to create that double click stream. So I'm copying this in. And let's go through this. Variable, we're looking at the click stream.
Sorry, can you put it a little bit up so we can
larger?
see this?
Oh yeah,
Higher.
okay, yeah, higher up, like that?
Yep.
Okay, so we're looking at the click stream. And when an event arrives on this click stream, it starts this buffer operator. So it starts putting stuff into an array or into a bag. And the argument that buffer takes is another stream. So whenever something arrives on this new stream, it stops, it closes that bag and sends it on. And right here we are looking at the same click stream. So we get a value, we start buffering, and then this one will collect values for those 250 milliseconds, and then it'll pass it on and into the next chained operator that we have here. And we're filtering it, these clicks. This is an array of the events that came onto the stream. And we check here if the array length is equal to 2. Then I'm just mapping this over so it takes the original click and sends it on. And right now I don't have the UI update code, so I'm going to borrow it, and it essentially does exactly the same as the previous one. So you can see the similarities. So now, if I double click, 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 it moves. And you might notice that there's a little delay, and we're going to talk about that in a second. So bear with me. All right. So what I promised at the beginning was that we were going to look at reactive programming in React and Redux. And of course, since we're in the JavaScript world, there's tons of libraries. If you want to start working with reactive programming, then there's a bunch of libraries that would use different approaches and different levels of abstraction for this. But for this example, I'm going to use redux-observable because I know it and I've used it, and I think it's a really elegant way of just exposing RxJS in Redux. So it essentially just combines together React, RxJS, and Redux. So one thing I want you to take home here is that what really is going on here is that we're exposing the power of RxJS, and RxJS is really the foundation of this. If you learn reactive programming, you would use the same concepts you would use in RxJS in, for example, .NET or Java or Python or whatever. So any reactive programming you learn, you can bring to if you want to change programming languages at any time. And for RxJS in particular, you can use it with your favorite framework or no framework. In the examples we took right now, we used nothing. We used just the APIs that exist in the browser to render it. And you can do that too if you think that's awesome. But I'm going to use React and Redux together with redux-observable. So we're going to make a little simple app that notifies us when we've double-clicked. Let me jump over here. Can you see this? All right, I see a bunch of nods. So this is a very simple React app that I've got here. Notably, you can see that I'm importing RxJS, and what that's doing, it's importing all of the operators so we can use everything. If we look down a little bit, we see that we've got the Redux imports, what you would expect when you import Redux for use in React. Thirdly, we have redux-observable, and we create epic middleware and combine epics. And epic, that's a concept in redux-observable, and it essentially just means this is a stream that maps an action onto another stream. We'll take a closer look at those, but these functions are the ones to hook it up into Redux. And then I've organized my reducers and the epics into ducks. Some of you might be familiar with this pattern. If not, Google it. It's nice. So we're setting up our reducer. I've got a click reducer and a notifications reducer. And then we've got this root epic. And this right here, this is the first look we have at an epic. So it's a function that takes the action stream, and the action stream is what redux-observable adds in with the middleware. It's essentially just all of the actions that are dispatched onto Redux. If you dispatch something, then it goes into this action stream. And right now, I don't want to do anything with it, so I'm just returning this stream with the ignore elements operator, and then it just returns a stream that returns nothing. If you would return a value, it would need to be a Redux action. And then the app, it basically, we got our notifications component and a little clickable square. So it looks something a little bit like this. But first of all, first of all, what we're going to do is, if we click this, I've got a little logging middleware so we can take a look at what happens with the actions. So it's dispatching a click action. No, you can't see that at the bottom. I'm just going to have to describe it to you. So it dispatches a click action, and then the store contains a clicks object that counts up how many single clicks and how many double clicks and how many notifications you have. So if I double click this right now, click, click, nothing happens. It just counts up the single clicks. And if we look at the clicks duck, we can see that we can see the reducer here. It reacts to a click, and what it does is it increments the single clicks number. And if we get a double click action, it increments the double clicks number. If we go up a little bit, we can see our first epic. So I create a variable, I call it double click epic by convention, and it contains a function that takes the action stream. And inside of this, I create a click stream. And you might remember this from here. We have our click stream, and over here we create a click stream by looking at the action stream and filtering it with a helper function of type. And this is basically just a filter that filters on action type. So now we've got all the click actions in the click stream. And then what we're doing is we're doing the exact same thing as when we did the double click in JSPin. So what we have here is we buffer it, we debounce it by 250 milliseconds, and then we filter it on length 2 and map it over to the first one. So here we buffer it, debounce it again, 250 milliseconds. We filter it by click length 2, and instead of just passing the event, this time I'm choosing to just map it over to a simple action that's called double click. Because remember, an epic, it looks at actions, it takes the action stream, and then it has to map it over to the stream that emits actions. I export this, so now we can go back into index and we could change what epics we're using. So I'm going to comment out this one that did nothing, and I'm going to change the root epic so it contains the clicks epic. So now, as before, when I click, it dispatches the click action, but when I double click, click, it also dispatches a double click action. And if we look inside the store, the clicks object contains a 1 on double clicks. And I mean, I think that's cool. If you triple click 1, 2, 3, nothing happens because we looked at equality, not equal or larger than 2. So this is a way to just get the double clicks. So what did we want to do? We wanted to add a notification when you double click. And this is one of the things that I think is really nice about how RxJS and working with Stream works. And it's that I can still have all the behavior I have, but since everything's happening on a stream, I can create a new stream that does something else. So I'm going to start by commenting out and bringing in the notifications epic. We're going to look at it before we start playing with the click dude. Maybe it's a click lady. I don't know. So this combine epics, if you've used Redux, you recognize this from combining reducers. And it's, I think so, yeah. And it's essentially, no, combining middlewares. And it's essentially the same thing. So let's take a look at the notifications duck and the epics. If we look at the reducer first, it starts with just an array, and whenever an add notification action happens, it adds whatever's in the payload into the notification array. And let's look at the top here now. I create a double click notify epic. Notice that I'm not touching any of the clicks duck stuff. I just listen to, I just take in the action stream, and then I'm filtering on the double click action that comes from the click duck and the click duck double click epic. So now when I've done this, I've got a stream that only contains the action double click. And what I do with that is I map it, again very similar to how you would work with arrays, onto a normal, just regular Redux action with the type add notification, and it contains a payload that has an ID with a timestamp and a message that says you double clicked. So remember that I uncommented and I combined the two clicks, the two epics, the clicks epic and the notifications epic, into the root epic, and that's what it's listening to now. So as before, if I click it, it dispatches a click, and if I triple click it, 1, 2, 3, nothing happens. It just dispatches 3 clicks. But if I double click, drum roll, click click, yay, we double clicked. I am way more excited. You can do it again. When I actually wrote this code example, I just filled the screen. It's excellent. It's just excellent. Okay, so if you're starting to think about streams, maybe now you're thinking about, okay, what else can you streamify? Like anything that has events, you can streamify. And yeah, you're right. Anything you could streamify Ajax, you could streamify WebSockets, stuff that has to do with timing, like animation. Yeah, I'm going to stop with the examples there. I can't think of more. And essentially what you do is you just create a stream from whatever events or whatever thing that triggers a value, and then you would subscribe to it. Or in the case of React and Redux, you would dispatch it onto, you would just dispatch it and you would have it on the action stream. But don't actually do this too much, because most things that are commonly used are already written, so don't write that code again. And surprisingly, RxJS seems to be very stable in that way, in that if you're thinking about doing something, there's usually someone who's thought about it before or who has combined together operators to create that behavior that you're thinking about. So yeah, there's exists for Ajax and WebSockets and so on. I'm not too sure about the animation stuff, but I mean, I'm gonna take a guess. Yeah. Some things might not exist. Here at Acast, we have a online audio player that we've created with RxJS, redux-observable, React, and Redux. And in that, you have to listen to the audio element API. So I'm just going to show you a little bit what that looks like. Can you see this? I'm looking for the nods again. Yeah, I can see the nods in the back. So let's just reload this. And I'm going to mute the tab. And you can see the actions that are emitted from the start. We have the init, we have the app init, and on the app init we have an epic that reacts to, oh, there's an app init. All right, then fetch the episode. And we've encapsulated a thing called the play service, so it fetches from the play service, and then it says, hey, it dispatches, I've fetched. And then after it dispatches that, it knows that, oh, I wanted to fetch the episode, and now that that one's done, I'm also done. And then we dispatch episode ready, and then the whole fetch stitch thing is fulfilled. So if we start playing, there's a bunch of stuff happening. I'm going to scroll up. So play episode is dispatched, and then a player will start play batch is dispatched. The episode isn't loaded yet, so all right, load that episode. And then it knows we will load an episode, then we can react to that on the UI. And then it does the actual load. And here in Sound Engine, that's an encapsulation of the audio element API. So that one starts spitting out whatever audio events happen, like empty, the time updates. And when we come down to, let's see, this can play through, then we know that, all right, we loaded the episode enough so that we can play it. Then we dispatch out a do play. It starts playing it. The audio element reports that. Then we know that it did start the playback, and then we get the time updates, and so on and so on. And this is all orchestrated by a bunch of epics that does things like, oh, I haven't loaded this thing yet, so dispatch this thing and then wait for this other action to come in. And then when that action comes in, continue with the job that you were thinking about doing. So you could kind of view an epic as a plan of action. And depending on what has happened or not, it either dispatches stuff or continues on. Any questions on that? That might be the most dense portion right here. All right, cool. Let's see. I don't know what's next. Okay, yeah. What's cool about this? The coolest thing is that you change your mindset. At least I have a little bit. So I start thinking about behaviors instead of exactly how I'm supposed to implement it with operators and for loops and ifs and... I'm just kidding. I'm not using for loops. And I find myself thinking less about the implementation details and a little more about how my app is supposed to behave. So it's not just a dance on roses. I don't know if that expression really translates, but it's not. The first annoying thing is that you got to learn RxJS, and as soon as you start diving into it, you realize it can get kind of hairy. And the best way of showing this is to show you an example. So let's jump back to the JSBin one. And you know, I'm double-clicking, and it takes a little while for it to actually jump over and show me where the double-click was. And of course, we can solve that with just operators and streams and stuff. And I'm going to copy this over here. And we're going to create a stream that I want to call stop waiting for another click stream. Fantastic. Oh, I actually had it over there. Sorry. And now if we put that in there, stop waiting for another click stream. If we run it, click, 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 click. So it jumps immediately. We don't have click, 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 click. We don't get triple clicks anymore because it stops listening after 2 clicks. So let's have a look at this. What is this stream? So we're looking at the click stream, and then we're using an operator called exhaust map. Exhaust map, okay. So exhaust map takes a function that returns a stream, and when that stream has completed so that it won't ever get any more values, then it emits a value. Let's take that again. So it looks at the click stream, and then based on when this stream ends, it collects values and then emits them. So what we're returning here is a stream, the click stream, but it's merged together with the timer that emits after 250 milliseconds. So let's think about that. The click stream gets the clicks, and the timer it emits after 250 milliseconds no matter what. So it's going to get both of those things on this stream, both clicks and that one timer emit thing. And what completes this stream is this take operator. It will only take one value, and then it completes the stream. Then the stream's done. It's never going to wake up again. If you want to wake it up, then you'll have to start from a stream that's still alive. So, again, we're looking at the click stream, and we're waiting for another stream to complete, and that stream completes either when there's a click or when 250 milliseconds has passed. And after that happens, that array of 2 or 1 clicks come into this filter, and we can filter on length and then go on as usual. Don't worry if you don't follow along 100%. It takes a bit of time to get used to, and I mean that is a drawback. You're basically alienating a certain set of some developers who don't know it or who aren't interested in learning it. But it's kind of like mathematics. I'm sure that every one of you has had a math teacher that says like, no, but I love math because it's so easy, it's so simple. You can express complex things in the simplest of ways, and yeah, it's true. But you kind of have to learn it. But it is very expressive, and I think it's worth it for the expressiveness. And then quickly, I'm running a little bit over time. Just 7 quick things to keep in mind if you want to dive into this and learn more about this. So the first thing, there's always an operator. As you saw, it might not be the most straightforward thing or to wrap your head around, but there's essentially always an operator. And keep that mantra, repeat it over and over again. When you can't get something to work, there's always another operator. Some operators expect streams and some expect values, and this ties back into the understand streams and what they are. Otherwise you can end up with things like a stream of streams. And while that's a cool, like, matrix-y kind of thing, it's a real bleep headache. So mind what your operator expects. You can find it in the documentation. When you start, you're going to use flat map and switch map quite a lot. I think you're going to use these and want to grab this in the toolkit a lot of the time. Switch map, what it does, it completes the previous stream, and then it replaces it kind of does an Indiana Jones and replaces it with a new stream that you give it. And that's nice. You don't have to keep track of the old stream. Flat map, or what it used to be called merge map, it just merges two streams together. Stream A and stream B, they emit things, and you get stream C that has the values from both of them. But now, all of a sudden, you have two streams going on at the same time. Headache? Yeah. Another thing. RxJS is heavy. Don't import all the operators. You saw me doing this. Import RxJS. This is bad. You're going to tear people's internet usage up. So what we do at Acast is we have like a file where we import the operators that we're using and keep track of it. It's a little bit of a bookkeeping headache, but yeah. For redux-observable, reducers get the action first, then the epics. There's a joke in here. I'm not going to explore it. But if you use this, know that the reducers, they do their reducer magic first, and then the epics get them. And a side effect of that is that you can look into the store and get the calculated values. If you want to do side effects in redux-observable, you already saw the ignore elements if you don't want to continue or don't want to do anything. But then there's this operator called do. And what it does is it just executes the function and you get the value onto the from the stream to the function, but it doesn't actually create a new stream. What we use this for here is for tracking or logging. I don't know, maybe you want to play a sound with it, I don't know. The last thing, each observable has its own runtime. The first example, we had a thing that counted up. And we could see that by subscribing to it. And when we subscribe to it, we create a runtime. And it starts counting up. But if you would subscribe to it and then do a set timeout and subscribe to it a second time, 250 milliseconds later, then it wouldn't actually continue where the first one is counting. It would start a new counter. And if you actually want to share a runtime between subscriptions, then you want to look into subjects. But really know what you're doing if you're creating a subject. That's it. And I think we have about 4 minutes for questions, if there's anyone.
Take more time for questions.
And if you want to go and get more beer and pizza while we're doing questions, feel free. Anyone who has a question? Yes?
About that real-time example you showed. If I get it right, like most of your streams is like they subscribing to event and then raise like some handler or like firing some action to like starting some task. And then another stream subscribes to event indicating that task is done and then starting another task like this.
Yeah.
So this really looks like event handlers, and event handlers sounds like spaghetti code, if you get what I mean.
Mm-hmm.
So what if you need to like what if you need to perform a series of actions, asynchronous of course,
Mm-hmm.
and if you want to have all the code in the same place, like what do you do? You don't use strings or what?
Are you talking about the audio player example?
Yeah.
Yeah. So what we do there is what's actually happening is that, say that you want to play something. That's what I was clicking on. So what it dispatches onto the action stream or into Redux is please play. And inside that one, there's an epic called I think play episode. or something, play episode epic. And that one essentially has these the checks in place. Like, is it loaded? If it's not loaded, then it stops. And then it waits for the stuff to get loaded. And it checks whether it's loaded or not by watching for the actions that it's loaded. And then we've got like IDs and stuff to keep track of what actually was loaded. So it, like in my mental model, it's kind of like it goes down the operators, and it says, I want to start playing this, and if there's some step that isn't done yet, then it can just dispatch an action and then wait for another action to be dispatched on the action stream.
But
and then it just pauses there.
Yeah, but it's not that stream who waits for that action. Like, it dispatches some action, like we didn't load the file yet, and it dispatches please load the file function. And how does it know when this function has ended? It doesn't know. It just another event or
you create another stream that is alive until that loading complete action happens. And then when that loading complete action happens, then you continue with the original stream that you had. So it's like stream and a stream, and stream and stream, and then if you need to do more stuff, you add a stream in between. So you kind of split streams and add them in between each other.
Yeah, I get it.
It's mind-boggling. We can talk more about it.
Yeah.
Anyone else?
Are there any profiling tools to visualize stuff?
So for checking performance for this?
Not only the performance, but you showed us Redux sort of plugin or extension.
Yeah.
Is there any analog for the streams? To visualize the streams to see how they're created.
So is there any tools to visualize the streams that you're starting? Not that we've used. So if you find one, please send it to me. Is there any way to unit test? So if you go up to redux-observable's documentation, they have examples of how they would unit test things. But essentially, you would unit test them similarly to how you, in the redux-observable world, to how you would test a redux reducer. But they do admit that they haven't found the perfect way at Netflix on how to unit test these things. Yes. All right, thank you.